video is an introduction to logarithms. We'll talk about what logarithms are, we'll talk about how to compute simple logarithms, and also how to convert from a logarithmic equation to an exponential equation, and from an exponential equation back to a logarithmic equation. Let's get started. First, let's talk about how to read this. It is read log base b, so this little letter that's down here, the number that's down there, is kind of a subscript. It's called, we say it's base because it will be the base of our exponent, okay? So we say log base b of a, and the of a is kind of function notation, way of saying that, okay? So log base b of a is how we read that, okay? And the way I want you to think about logarithms is as in what power, okay? So the base to what power is equal to a. All right, so we'll kind of keep going over that idea. The base of the logarithm to what power is equal to the number in the parentheses. Okay, two more things you have to know before we get started. If there is no base shown, it's base 10. Okay, and that's because our numbering system is a base 10 numbering system. Okay, we start with 0, write the numbers 0 to 9, and then at 10 we write 1, 0. Okay, and we have a base 10 numbering system, and so log with no base is base 10. Okay, there's also a number that is used a lot in calculus and beyond, and that is a new number for us. It's the number e. Okay, the number e is approximately equal to 2.718. 8, and it goes on. Okay, actually e is a number like pi where it goes on forever without any pattern. It's just that it's less well known than pi is. The interesting thing about the letter e is that's the base of the exponential equation, so e to the x, where at every point on the graph, the y coordinates, it's the same as the slope. And that's an interesting thing that happens in calculus. And so that's used a whole lot more in calculus, but at least for our class, we'll begin to look at log base e, which is called the natural log. It's usually written as a cursive, the natural log. Okay, so with that in mind, let's jump in and look at some of the rules of logarithms. Okay, so log of 1. Now, if there's no base, it's base 10, remember? So you think about 10 to what power is 1. Okay, and because 10 to the 0th power is 1, then the log of 1 is 0. Okay? Now for b, log base 2 of 1 is what you're thinking of as 2 to what power is 1? Well, 2 to the 0th power is 1. So the log base 2 of 1 must be 0. Well, what about 5? Log base 5 of 1 is 5 to what power is 1? And because 5 to the 0th power is 1, then the log base 5 of 1 must be 0. Okay, and hopefully you're seeing a pattern. We're kind of building up to a rule. Base 1037 is 1037 to what power is 1? Well, I happen to know that 1037 to the 0th power is 1. And so the log base 1037 of 1 is 0. Okay, and I think I can generalize from there, okay? I could do 3 more, but the point is anything to the 0th power is 1. So the log base b, any base of 1 is 0 because to any number to the 0th power is equal to 1. Okay, so if you ever see a log of any base of 1, know that that's going to be equal to 0. Okay, 2 other rules to talk about. Log base 10 of 10. Remember that if there's no base written, it's base 10. So log of 10 is 10 to what power is 10, and because 10 to the first power is 10, then the log of 10 is 1. Okay, the log base 2 of 2, you're thinking 2 to what power is 2? And because 2 to the first power is 2, then the log base 2 of 2 is 1. Okay, so the log base 7 of 7 is equal to what? Well, 7 to what power is 7? And it's the first power. Log base negative 7 of negative 7 is 1 because negative 7 to the first power is negative 7. Okay. Now, as a side note, we don't typically talk about negative bases because weird things happen when you have exponents of negative bases, like they can't be even and weird things happen. So, but in this problem, I can look at that because it's just 1. Okay, so the identity rule is log base b of b is 1 because any number, any value to the first power is equal to itself. Okay, one more rule to talk about, and I don't think it has a name, but it's the idea that if you have a base, so log base 12 of 12 to the 13th, then you're asking yourself 12 to what power is 12 to the 13th? And it's 13 because 12 to the 13th is 12 to the 13th. Okay, so that if you have the same base and then like a base of an exponent that are the same, then the exponent is what it's equal to. So log base 20 of 20 to the 32nd, you're thinking 20 to what power is 20 to the 32nd, and that's 32. Okay, and finally, log base 81 of 81 to the 200th is 200. Okay, so the log base b of b to the m is equal to m. So keep that in mind. Okay, those are 3 rules that'll be useful for us, but more important is that thinking of, hey, the base of the logarithm to what power is the number inside the parentheses. So let's evaluate some of these expressions. The log of 100, again, if there's no base, it's base 10. So 10 to what power is 100? Well, 10 squared, or second power, is 100. So that's 2. Log base 2 of 8 is 2 to what power is 8? And 2 to the third power, 2 cubed, is 8. Okay. Log base 2 of 64 is 2 to what power is 64? Well, I don't know. I got to count it out. So I have 2, 4, I'm counting my fingers, 8, 16, 32, 64. I got 6. So 2 to the 6th power is 64. Okay? And I could keep going down, but I think that's enough to kind of get the hang of those kinds of problems. All right. The ones down here get a little more complicated, and we'll use a method that we used earlier, which has to do with using a common base to solve an exponential equation. So the log base 1/3 of 9 is asking the question of 1/3 to what power is 9? And if you can't do that in your head, that's fine. Okay? If you can do these in your head, go ahead and write it down and keep moving. But you may not know what 1/3 to what power is 9. So I can write out 1/3 to the x power equals 9. Okay, and then I can write both sides as 3 to some power. So I kind of take there in steps. 9 is 3 squared. I'm right here. 9 is 3 squared. And then I can write 1/3 as 3 to the negative first power. Okay, and then I can bring that negative outside of the parentheses, and then at this point, I can say, oh, I have the same base of the exponent, so negative x must be 2, or x must be negative 2. Okay, which as I go back, I can realize, oh yeah, the negative will flip over the fraction, and the 2 will square the 3, and that makes sense. But maybe at first, you couldn't think that through, and that's okay. All right, log base 9 of 3 is 3 to what power is, 9 to what power is 3? And you can again use common bases and write 3 squared as 9. And then you have this power rule where you have an exponent to an exponent, you multiply 2 times x, you get 2x, and 3 is just 3 to the first power. So you get 2x is equal to 1, and you divide both sides by 2, and you get x is 1/2, which I guess makes sense because a square root is also the 1/2 power, and the square root of 9 is 3. Okay, let's do some of these on our own without kind of walking through those steps so I can kind of talk through it as I go. The log base 2 of 1/4 is asking the question 2 to what power is 1/4? Okay, and if you don't just know it, then let's kind of think through it using common bases. Well, I'll write both sides to the same base, and I'll take this in small steps. So 4 I know is 2 squared. And then I can change which side of the division bar it's on by changing the sign of the exponent. So if I move this up, I get 2 to the negative 2. Okay, and then I have the same base of the exponent, so x is equal to negative 2. So I get negative 2 right here. Okay, let's do one more. I think m looks a little scary because of that square root in there. Okay, so I'm asking myself, this is m. I'm asking myself log base 5 of root 5 is 5 to what power is root 5? 5 to what power is the square root of 5? Okay, well, I'm going to write them as with the same base. And so I have 5 to the x is equal to, now, we can write this as 5 to some power, and a square root actually is the 1/2 power. And the way you can see that is if you square both of them, the square root goes away, right? You get 5 either way. So if I square this one, which I shouldn't do, like I'm changing the value, but I'm looking at just this piece right here. If I square this, then it's equal to 5. If I square this, the 1/2 times 2 is 1, so I also get 5, okay? And because you get the same thing by doing the same thing, they must be equal to each other. Okay, that's my quick explanation about square roots are the 1/2 power. Okay, so that means that x must be equal to 1/2 here. So I have 5 to the 1/2 power is the square root of 5. Okay, and you can think through any of those that have common bases. Okay, let's move to our second bullet point, and that is writing a logarithmic function as an exponential function, and then we'll try later on to go from exponentially function back to logarithmic function. Okay, so log base 3 of 27 is 3. That's a true statement. Okay, and I'm thinking 3 to what power is 27? Well, they've told me it's 3. 3 to the third power is 27, and I know that that's actually true because I can multiply 3 times and I get 27. Okay, log of 1,000 is 3. Again, there's no base, it's base 10. So I think 10 to what power? Oh, it's the third power is 1,000. So I'm just rewriting those by thinking through to the what power. Now, the natural log, again, is base e, that new number that we just kind of introduced today. And I'm thinking about e to what power? Well, the power they told me is 3.999. 3 to what power is 54.598. Okay, that's going from a logarithmic function to an exponential function. Okay, let's go the other direction and go from an exponential to a logarithmic function. Okay, so I have log, and the base is the same as the base of the exponent, so it's 16, of what number? 64. Okay, because the number I get over here is the power. Okay, and I can go backwards by saying, okay, 16 to what power is 64? It's 3/2. Okay, and so you have the base. This base of the exponent is the base of the logarithm. Okay, and then what it's equal to is the power, and so what you're left with is that number on the equal sign. I don't know if that makes sense or not, but here we go. Letter B. Log, I'll use the same base as the base of the exponent, which is 10. And I'm going to be fancy and not write my 10 because if nothing's there, it's assumed to be 10. Okay, of the number 0.01 is equal to the exponent of negative 2. Okay, and letter C is the log base e, but I remember that log base e is written as the natural log. Okay, the natural log of the number 20.0856 is equal to the exponent of 3. Okay, that's going from exponential functions back to logarithmic functions. Let's try one more kind of problem before we end, and that is if f of x is log base 2 of x, then I want to evaluate some of these. Okay, so f of 16 would be the log base 2 of 16. Okay, this one I can do in my head. So 2 to what power is 16? Well, I count off on my fingers. 2, 4 times 2 is 8 times 2 is 16. That's 4 times. Okay, so 2 times itself 4 times is 16. Okay, f of 1 over 32 is the log base 2, that's the function, of 1 over 32. Okay, well, fractions make me think about having negative exponents because that negative would flip over the fraction. Okay, so I'm asking myself 2 to what power is 32? Well, I just did 4 is 16. If I get one more, I get 32. So 2 to the 5th is 32, but it's 1 over 32, so I get a negative 5. Okay, the last one is a little more challenging, and that is f of root 8. Okay, the function again is the log base 2 of, so root 8. I'm thinking about this through. So I can't do this one in my head. 2 to what power is root 8? So if you can't do it in your head, it's okay to go down here and say 2 to what power is the square root of 8. Now I'll use common bases, and I just have 2 to the x. So I'm going to use the common base of 2. And 8, I know, well, let's start with the square root. I know that the square root is a 1/2 power, so it's 8 to the 1/2 power. And then I'll write 8 as 2 to some power, and I know that 2 to the 3rd power is 8. I'll just replace that with 8. And then I will use the power property and multiply these two together. And 3 times 1/2 is 1.5. If you're really fancy, you'll use 3/2 as a fraction, but that's what I get. So this is equal to 1.5. So 2 to the 1/2, 1.5, or 3/2 power is root 8. And it just kind of makes sense because the 3 on top, I think makes more sense as a fraction, 3/2. The 3 on top will cube it to give you 8, and the 2 on bottom will give you the square root. So it kind of makes sense once you're done, but you may not be able to see that at the very beginning. All right, this was an introduction to logarithms. We talked about what logarithms are, how to compute simple logarithms, and how to go from logarithmic equations to exponential equations and back. Thank you for watching.